right, welcome to The Explainer. Today, we're going to cut through all the noise from the diet wars to tackle one massive question. Can you actually truly live without eating carbohydrates? Let's dive into the science. So let's just get right to it. Could you really just ditch all the bread, the pasta, even the fruit, and not just survive, but actually thrive? Is that even possible? Are carbs something our bodies absolutely must have? Okay, so to figure this out, we have to start with a really basic question. Are there any parts of our body, any cells at all, that are super picky eaters? You know, the kind that will only eat carbs for energy. Because if there are, well, that kind of settles the debate, right? And the answer is a big yes. There is one type of cell in your body that absolutely, exclusively has to have carbohydrates. I'm talking about your red blood cells. And the reason why, well, it's actually super cool. It all boils down to its one incredibly important job. Think about it like this. The red blood cell's mission is to be the perfect oxygen delivery truck. And to do that, to maximize every last bit of space for oxygen, it does something radical. It literally throws out its own engine, the mitochondria, the cell's power plants. And that's where things get really interesting. See, without that engine, without the mitochondria, these cells can't burn fat or protein for fuel. No way. They're left with only one choice, a special process called anaerobic glycolysis. And the key part of that name? Anaerobic. It means it creates energy from glucose without using any oxygen. This just makes perfect sense, right? You can't have the delivery truck eating the package it's supposed to be delivering. That would be a total disaster for the muscles and organs waiting for that oxygen. Okay, so we've got it. Red blood cells need carbs. Case closed for them. But what about the real energy hog in our body, the big boss upstairs, our brain? Oh yeah, the brain is an absolute glucose monster. Just look at that number. It chews through a massive amount of glucose every single day. That's what's powering, well, everything you're thinking and doing right now. So that begs the question, right? We all know fat is super energy dense. It packs way more punch per gram. So why on earth doesn't the brain just use fat for fuel? Well, it really all comes down to a classic trade-off: power versus speed. You can think of fat as the slow-burning, powerful log. But glucose? Glucose is like high-octane gasoline. It's fast, it's efficient, and it gets across that protective blood-brain barrier with no problem. Our brain's neurons are firing like crazy. They need fuel right now. And honestly, glucose is the only thing that can keep up with that demand. Okay, so let's recap. Our red blood cells need glucose. Our brain is a huge fan of glucose. It kind of sounds like we're totally locked in, right? Like we absolutely have to eat carbs. But is that really the whole story? Well, not exactly, because our bodies have this incredible, almost magical survival hack built right in. It's called gluconeogenesis, which is just a fancy way of saying your body can literally make new glucose from scratch using things like proteins and fats. And it's not just a little bit. Your body, mostly your liver, with some help from your kidneys, can pump out enough glucose on its own to cover all the baseline needs of your brain and your red blood cells. It is an absolutely amazing survival tool. So what does that mean? It means, technically, from a pure can I survive perspective, you can live without eating a single carbohydrate. Your body has you covered. It's got a backup plan. Okay, but surviving is one thing. What about thriving? Well, there's another piece to this puzzle. When you're not eating carbs, your body starts breaking down fat and creating this alternative fuel source called ketones. And what's truly remarkable is that over time, your brain actually learns to use these ketones for energy. It adapts, becoming less and less dependent on glucose. All right, but this is where the conversation takes a sharp turn, because there is a huge difference between just fueling your body for daily life and fueling it for peak athletic performance. Surviving is not the same as winning. And when you look at the raw data, the reason starts to become pretty clear. One single molecule of glucose gets you more bang for your buck. It produces more ATP, that's the energy currency of our cells, than a ketone body does. It's just a more efficient fuel when the demand is high. But that's not all. Here's another massive advantage for glucose. You can pack it away right inside your muscles as glycogen. It's like having little fuel tanks on site, ready to go. Ketones, on the other hand, they can't be stored there. They have to be made in the liver and then shipped out to the muscles. That's a delivery delay you just can't afford in a race.
And this right here might be the biggest deal breaker of all for high-intensity athletes. Think about those all-out efforts, a sprint, a heavy lift. That requires anaerobic energy, meaning energy created without oxygen. And guess what? That is a metabolic pathway that only glucose can fuel. Ketones just can't play in that arena. They are completely shut out.
So for an athlete, especially in endurance events, this is everything. It's the difference between having that final kick to finish strong or hitting that dreaded wall because your on-site high-octane fuel tank, your glycogen, is completely empty.
So, where does all this science leave us? After all that, what is the final answer? How many carbs do you really need?
And the big takeaway is this: there is no single magic number that works for everyone. It's not a one-size-fits-all situation. The right amount of carbohydrates for you depends entirely on your lifestyle and, most importantly, on what your goals are.
So let's say you're an athlete on a low-carb diet and you feel like you've hit a performance ceiling. What do? Well, you can find your personal sweet spot. It's all about careful experimentation. You start to strategically add back in some carbs, maybe right around your hardest workouts, and you find the absolute minimum amount you need to fuel that performance without derailing your other goals. And that really brings us to the final question, the one that only you can answer. Now that you understand how your body adapts, how it uses these different fuels, what is the truly optimal fuel source for your personal goals? How are you going to choose to fuel your machine?